Hi, hello everyone. So we're now familiar with the two-way or the three types of equation of a circle. We have the x squared plus y squared equals r squared version for a center of 0, 0 and a radius of r. We then have the x minus h to be squared, y minus k to be squared is equal to r squared for the standard shortened version of a circle with a center that's not 0, 0 and a radius of r. And then we have the longer form of that, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Where you can just expand that out. So today what we're going to do is how can we find those equations when we're given very limited information about the circle itself. So before we're going to do that, we're going to do a quick revision of some little things that will help us out here. Okay, so I'm just going to draw 3 circles as we are want to do. Circle 1, circle 2, and circle 3. Right, so as you see, you have 3 circles drawn here. So finding the equation of these circles when you have limited information can be quite difficult. So sometimes it's handy to kind of have a little couple of tricks up your sleeve, for want of a better word, in order to kind of find what you're looking for. So I suppose trick number 1. And obviously this all has to be done mathematically, but it's good to visually show you what the tricks are. Trick number 1 is probably the easiest trick. Okay, if you get any chord, in other words, a chord is a line that touches from internally from one side of a circle to another. The biggest chord in a circle is, of course, always the diameter. Okay, if you have a chord and you bisect that chord by finding its midpoint, then a perpendicular line through the midpoint will always go through the center. Okay, so if it's a perpendicular line through the midpoint of a chord, it always goes through the center. So you can use a couple of little strategies there. If you know those 2 points, you can find its midpoint. You can also find its slope, which means you can find the slope of that one. You know, if you found it, and then you can use a perpendicular distance type of situation and stuff like that. So there's loads of different kind of methods you can get around that one. Similarly, it works the other way around. Okay, so if you have a chord, let's draw a chord here, and you have another chord, let's draw it here, and you do the same thing. You get the perpendicular, you can make them overlap that type of way. And this works backwards as well. If you drop a perpendicular from a circle to a chord, and cuts it in half. So this works backwards as well. Okay, just so you know. And I suppose the third one, the one we probably used a few times already, if you have a single point, tangent to that point, and draw and connect that through what you think is the center, that's always going to be a right angle. Okay, so there's a couple of little strategies you can use. But again, what I would suggest is when you're doing these questions, a quick sketch. Now, you don't have to use a ruler or any of that type of stuff, but a quick sketch will visualize what information you might have, and it might actually help you kind of do it. So, here's our first scenario. So a circle has 3 points, 2, 1, 0, 5, and -1 and 2. We'll call that A, B, and C. Okay. So I'm going to give you a bit of help here. There's B, there's C, and there's A. Okay, and the question is, can you find the equation of the circle? That's all I'm asking you to do. Find the equation of the circle. Right, so let's do a couple of strategizing on this one. Okay, what do we know for sure? Well, I know for sure that if I get that as a chord, and that is a chord. Okay, if I can get that as a chord and that as a chord, then I can find the midpoints of both, draw lines perpendicular through those midpoints, which will meet at the center. So there's a couple of different things that are going to come into play here. Okay, first of all, finding the slopes, finding the midpoints will give me a point and the inverse slope that I need for my y1 to get this equation. Let's call this for the L1. It's the same thing here to get L2. The simultaneous in L1 and L2 will give me the center. And then the question then becomes, how do I find the radius? Okay. Well, you know, the radius will just be the distance from that to any of those points. So you can see there's a multiple stranded approach that we're going to have to deal with here. But let's dive right in because I think it's going to be super cool. Okay. So we're going to need to get the centers of those circles. So we're going to have to find midpoints and slopes. So let's get AC. We'll deal with AC first. We want its midpoint and we want its slope because we need the inverse slope for L2. Okay, so AC, where are we? A is 2, 1. C is -1, 2. X1, Y1, X2, Y2. Let's get its slope. So its slope is going to be Y2 minus Y1, 2 minus 1, over X2 minus X1. So that's going to be 1 over -3, which means the perpendicular slope. So L1's slope of L1 is going to be, well, if it's 1 over -3, then it's going to be 3 for the slope of sorry, we're doing AC, so it's L2, sorry. Okay, it's L2. So we've got the slope for L2. Now we need the midpoint. We need something here to help us. So again, I'm going to go back to this. How do we get midpoint? Midpoint, it's add the x's divided by 2. So 2 minus 1 is 1. So it's a half. And then 1 plus 2 is 3 over 2. So there's your midpoint. Okay, so that's the point I'm going to use. So a half and 3 over 2, x1, y1. Okay, so let's get the equation of L2 then. So it's y minus y1 is equal to m on x minus x1. Okay, y minus 3 over 2 is equal to 3x minus 3 over 2. Multiply everything by 2. 2y minus 3 is equal to 6x minus 3. 6x minus 2y is equal to 0, I think. Okay, so there you have 1. So that's 6x minus 2y equal to 0. So that's him done. There's a lot of work in this. You can see this. This is not your bread and butter. Oh, this would be a nice easy one to get. This is going to be, this is your, this is a good 10 marker. So you're talking a good 5 or 6 minutes. Okay, now I'm taking me time on this. I would have got probably skipped about half of those lines, but I'm doing this step by step. Now we have to do BC. Same thing again. Let's get B and C down. 0 and 5 and -1 and 2. x1, y1, x2, y2. Let's do this one quicker. Add the x's, divide by 2. Okay, it's a half, minus a half. Add the y's, divide by 2. Okay, so that's this point here. Okay, now when you get to the slope, y2 minus y1 over x2 minus x1. So that's 3, so it's minus a third. This is the slope I'm looking for. So x1, y1. Y minus y1 is equal to m on x minus x1. Bottom left, top y, 3y minus 21 over 7. So over 2 is equal to minus x minus a half. Multiply everything by 2. 6y minus 21 is equal to minus 2x minus 1. So that's going to be 2x plus 6y minus 20 equal 0. Okay, so simultaneous them, I suppose, Getting very messy, I know, because I'm trying to squeeze it all onto one page, but listen, that's the beauty of rewinding. Okay, so simultaneous these two. We've got 6x minus 2y equal to 0, and we've got 2x plus 6y equal to 20. I'm going to multiply the top line by 3. 18x minus 6y equal to 0. 20x is equal to 20, x is equal to 1. If x is equal to 1, x is equal to 1, y is equal to 3. So that's 1 and 3 in the center. So now I need to find, run out of space. Run out of space, okay? So we need to find the distance between 1 and 3 and any of the points. 1 and 3 and 0 and 5 is probably the easiest one to do. I'm using a new sheet of paper, if you don't mind. Okay. So what have we got? 1 and 3 and 0 and 5. 1 and 3, 0 and 5, x1, y1, x2, y2. Let's get the distance. X2 minus x1 to be squared plus y2 minus y1 to be squared. That's square root of 1 plus 4 equals root 5. So the radius is root 5 and the center is 1, 3. So if that's the case, 1 and 3 and root 5 is our x minus 1 to be squared plus y minus 3 to be squared is equal to 5 is your is your standard formula, your shortened formula. You can multiply it out if you want, if that's the required one. Okay, if you want the longer one. 1, 10, 6. Sorry, 1 minus 10, 5. There's the general formula if you really want it. Okay? So, oh my God, that was epic, wasn't it? I nearly have a sweat after that. It's a lot of work. Okay? You know me, I'm not the neatest human being on the planet. You know, I'm trying to do it across the page, but the reality is I'd be doing this down on a sheet. You can tidy up this to probably half this work if you know what you're at. You know, you don't have the right, if you're doing the midpoints and you're doing the slopes, you should be able to do them nearly in your head at this stage. If not, do them on a calculator. You know, you can always double check the answer again. Funny little thing that they were obviously at right angles to each other. You can see that by the slopes. One slope is the perpendicular of the other slope being the perpendicular. So there are of course other methods of doing this. Nobody's literally going to shoot you on this one. You can, if you want to, do a simultaneous. Okay. I'm trying to think. Yeah. So you can do a simultaneous on it. Okay. Now, here's my caveat for doing the simultaneous. Okay. I would tend to only use the simultaneous. That's it. If one of the 3 points is 0, 0, then I'd be more inclined to do a simultaneous version of what I just did there. So imagine the exact same scenario, A, B, and C, you know, but this time one of the points is 0, 0. Then it makes sense to just create 3 simultaneouses, and you'll see what happens. So let's use our general formula. X squared plus y squared plus 2gx plus 2fy plus c equals 0. We'll do it first with 0, 0. What happens? Put in 0, 0. They all become 0, so c is 0. Straight away, you've got the constant. Okay? Now we'll do it with 3 and 1. That becomes 3 squared plus 1 squared plus 2g times 3 plus 2f times 1. We know it's c plus 0 equals 0. Okay? So 3, that's 9, plus 1 is 10. So 6g plus 2f plus 10 equals 0. So there's one simultaneous equation. Now do it with 3 and 9. Okay? Bing a bong a boom. Let's do it with 3 and 9. That's 3 squared plus 9 squared plus 2g times 3 plus 2f times 9 plus 0 equals 0. So that's 3 3s are 9 plus 81 plus 6g plus 18f plus 0 equal 0. 81, it's 90. 6g plus 18f plus 90 equals 0. You can see it's a simultaneous for f and g. Okay. If that wasn't 0, 0, then you get a triple. You get 3 of them. Okay. And, you could just try and substitute one into the other using your method of doing a triple simultaneous equation. But, and this is my big but on it, I would not go down the triple route if I had 3 separate coordinates. In other words, if I had, that was 4, 2 or 7, 5 or whatever the hell it was, I would not go down the triple route of trying to do a simultaneous equation. You know what I mean? I would only do it this way if one of the points is 0, 0, because it is so much quicker. You can see that. Okay, you can see it's ultimately like crazily quick compared to the other way. I would only do it if one of the points is 0, 0. Otherwise, I would go back and use the other method. Get your midpoints, get your slopes, invert your slopes, slope, inverted slope plus midpoint, y minus y1 formula. Give me two equations, simultaneous them, get your center point, then get your distance formula to one of the exit points, and away you go. I would do that method because it's tried, it's tested, it's using formulas you're comfortable with from the junior cert. It's a lot easier. Doing 3 of these, nightmare. Okay. Absolute nightmare. Okay. Because listen, the reality is it's not going to be worth 15 marks. It's not a chance. And remember, you know yourself, most triple simultaneous equations you get in the algebra section are worth 15 marks because there's a hell of a lot of time. You're talking 7 to 8 minutes to get it done. You don't have 7 or 8 minutes to get it done if you're only getting 10 marks for it. You just don't. So don't go down that route unless you see it's a 0, 0 and it's as clear and it's crystal clear that that's what it is. Okay. So now, what other what other craziness can we kind of get going here? You could have scenarios where you have limited information in terms of. I suppose I'll do one for you just to kind of show you. No harm in showing you again. Don't draw it like this. I'm just trying to make it pretty looking. Let's say you have a scenario where you don't know the center. Okay, you haven't a clue, but you know that there's a line going through the center, and there happens to be a chord. Okay, and you just happen to know the equation of the line, and you just happen to know the coordinates on the chord. So again, you have lots of strategies here, but you can see what you're really going to have to do. Okay, you're going to have to go for midpoint. You're going to have to go for inverted slope. You're going to have to go for new line. And of course, new line should intersect this line. And then where they intersect, you find that point and bing a bang a boom. Then you reverse it back and you find the distance. And you know where you're going with this. It's not crazy. So we'll do this pretty quickly. Okay, so let's go for this then. Let's do this in like record time. Let's try and get it done in less than 2 minutes. Okay, so you know the strategy. I'm going to give you, you take as long as you want, but I'm going to try and do it in 2 minutes. 3, 2, 1, go. And we're back. Okay, so let's go for this. We've got 1, 1. We've got 2, minus 1. x1, y1, x2, y2. Let's get midpoint. Midpoint is going to be add the x's, divide by 2. Add the y's, divide by 2. Okay, so not so bad. We've got midpoint. Now get slope. Slope is going to be y2 minus y1 over x2 minus x1. That's minus 2 over 1. That's minus 2. So the inverted slope is a half. That's the one I'm looking for. Okay, so we've got our point, x1, y1. We've got our slope. So y minus y1 is equal to m on x minus x1. 2y is equal to x minus 3 over 2. 4y is equal to 2x minus 3. And that's 2x minus 4y minus 3 equal to 0. Okay. Let's put them together. I'm only a minute into this. So we're going to simultaneous that with x. 2x minus y is equal to 7. So, okay, 2x minus 4y equal to 3. And we have 3x minus y equal to 7. Multiply that by 5 and change the sign. you're going to get, sorry, multiply it by 4 and change the sign, you're going to get a 12, and you're going to get a minus 12, you get minus 10, 28, minus 30, you're going to get, what is it? You're going to have, oh, I've lost it now in my own head, I'll have to do it out. Okay, 4, that's going to be 12x minus 12x plus 4y equal to minus 28. Okay, so we're going to have, what's this now? Minus 12, that's minus 10x, that's gone, is equal to minus 25. X is equal to 5 over 2. Okay, Christ, x is equal to 5 over 2. Could it make it any harder on me? X is equal to 5 over 2, pop that back in. Y is equal to a half. Okay, so that's 5 over 2 and a half. Okay, I've gone over the 2 minutes and 2 minutes and 10 seconds. So we're going to get a distance from there to there. Okay, x1, y1, x2, y2. So it's 5 over 2 minus 1 to be squared plus 1 over minus 1 to be squared and root the answer. Oh, mother of God, they made this any harder. Like, okay, 2.5 minus 1 squared plus 0.25. Square root of 10 over 2. Okay, so that's the radius. So my equation is going to be x minus 5 over 2 to be squared plus y minus a half to be squared is equal to 10 over 4. Okay, that's it. Sinead. Okay, that was about 2 minutes and 25 it took to do that one. Okay, not exactly rocketly quick. Got caught down here, didn't come out as nicely as possible, panicked a little bit. Once I got back past that though, it came nice. Okay, so Sinead lads, I'll see you next time.